Hello there. Today we are going to see something about chapter a rapid application development model, prototyping the spiral model. We are going to see about three what you call diagrams or process models in our video today. So in rapid application development model, we have got, if you see, I'll just go back to again in my previous videos. If you see, sorry, in my previous video I have shown you about waterfall model. What is that? Communication model, planning model, modeling, construction, and everything is the part of that, which I've got 5 states. So here when you go up this one, unified model, a rapid application model, we have got communication and planning. So each team is associated with this one: team, modeling and construction. Team 2 is again modeling and construction. Team 3 and development. We all integrated it. So rapid application development, and it is rapid. What do you mean by rapid? We have to go see this one: 60 to 90. You have to develop it. You have communicated, you have done planning, and then development and modeling process starts as early as possible. We have to take a time of this one. So this is a part of it. Now, red model description: an increment software process model having short development cycle. I just said you short development cycle, which is over 90 days, 60 to 9. High speed adaptation of waterfall model using component base. What do you mean by component base? Developing each one. This is one component, n component. This is second component, and this is first component. Based on that one, we are going to do this one. Create full functional system within the short period of 60 to 90 days. Multiple software teams are working parallelly. This is parallelly. They are working parallelly. One is other one. They are working parallelly. And construction use reusable component, automation code, and everything. So what does this? They are using reusable codes and all those things which are there. Problem: required number of teams, yes, and number of teams required commitment for both development as they has to communicate that I'm going to complete to 60 to 90 days, irrespective of whatever this rapid apply. Required modularity, not suited for technical. When we have a high risk, it is not suitable for this RAD problem. What do you mean by RAD? Rapid application development model. Correct. This is one. The next part of this one, evolution model, or we call it as prototype. Evaluation model, prototyping. There are this one: quick plan, modeling, then construction, development, communication. Communication, quick plan. We start with communication, quick plan, then modeling, then we have construction. This one. So it is just a prototype. What do you mean by prototyping? Develop one, go back to the customer, get a feedback. First go to the customer, develop, take the requirement, come back, develop a cycle, then go back to the customer, show the prototype, modify, if any modification, come back and do the requirement. This is what we have to do. Suppose if you develop a robot, what is that? You develop a robot, what you are going to do? You are going to do step-by-step process for it. You take a feedback, then you go to, it's nothing but a feedback process. If I told you up, it's nothing but a feedback process. It is a feedback process. So next slide. Prototype model description follows the evolutionary iterative approach. Used, required, not well understood. When you don't understand the requirement, you have to go for prototyping. You develop a part, you go there and modify. Once you understand the problem, you can able to do that. But if you are not able to understand the problem, you are going to do it. Serve as a identify mechanism for identifying software requirement, each and every. Focus on the aspect of software that are visible to the customer, which are visible to customer, which are not visible, we are not focused on. The feedback is used through, I just told you, feedback is used to refine the prototype. As I told you, we are going again to the customer and taking the feedback and developing. This is a process of feedback, correct? And this is one type. Then prototype modern potential problem. The customer seek work version of the software, want to stop all development, then buy a prototype after a few fix is made. What are the problem? Customer sees the version, buy them, then again say that this are going to change, I have to modify. There is a problem. Developer often make implementation compromise to get the software running quickly. Language choice, user interface, these are all very insufficient algorithm. So these are the part of it. So it is every time you are going to go and changes and everything. Lesson learned, define the rules. You're not going to define. You're not every time you're going to the customer and taking the feedback and doing final deposition of product before it is built. You don't have to deposit that. In most circumstances, plan is given to that engineer. Actual product is software is towards the quality. When you are going to give the plan and everything, you are going to get the quality. If any modification comes up, the quality of that product get disagreed if you modification every time. So irrespective, if there is a huge change, then quality becomes set. Now if I design anything, let's take an example. As you are engineering, as this is for engineering subject, you are writing an answer which is about 8 to 12 marks, and fortunately unfortunately you wrote it half right half wrong. Then what? You have to do it again. That is the problem here. You don't have to do it. Whatever the product you are doing, it should be very perfect. Then the comes up with evolution, spiral bonding. This is what we have: a development, delivery, feedback. They are running parallelly. Just see this one: construction, delivery, communication, planning, modeling, construction. These are running parallelly in a process. So each will go in a process. Start, each will go in a process. Correct? Spiral bonding, which was invented by Dr. Barry Bonham in 1988 while working in one of the organization evolution project. Used when requirement are not well understood. Again, this is used when the requirement are not understood. But here, if you see it, everything's are running parallelly. Whereas if you are here, see, they are not running parallelly. Correct? Here you see they are running. Inner spiral focus on identifying software requirement and project risks. Many also in crop prototype. Inner. What do you mean by inner spiral? This part of this one which are there in the inner spiral are used for what are the project risks, what are the software requirement of the outer ring task classify waterfall model approach where requirement have been identified and put in a iterative growth of a software. That is a part of it. Operators are high risk deval model, go on, decision occurs and everything occurs. Requirement are considerably taken. Expert in high risk assessment serve as a realistic model for large scale software. Do remember it. It was developed in 1988 and the inner circle goes on with the project risks and what are the software requirement and everything, whereas the outer ring goes with take the waterfall model and goes with the feedback process and everything. Risk model go not to go decision occur on each complete spiral cycle. Operation of risk divider go and not go decision occurs. So each risk decision we are going to take risk go or no go. What are the things are something like that. So general weakness of this one evaluation prototype model is prototype process problem to project planning because it is uncertain. The prototype poses a problem to project manager. A number of iteration goes up. Evaluation software process do not establish the maximum speed of evaluation. What is the speed of evaluation? How the evaluation are going on? A number of iterations goes up. If too fast, the process will fall. If too slow, product will get affected. There are two types. So software process should focus first on flexibility and then extendability. So general weakness of evaluation process model is that one is we have to got iterative problem, then how the evaluation work. If you're going too fast, the problem is going to focus and if you're going too slow, the product are going to get affected. Software product model should focus on flexibility, then extendability, and then we are going to go for high quality. I'll stop it here and for this today's video. Thank you very much.